Hi everyone, welcome to Requirements Analysis and Modeling. This is week 6 or lecture 6. Now today we are moving into Structured Analysis part 2. So the topic we are going to cover listed in this slide. So we are going to learn a little bit of revision about data flow diagrams, what we have covered so far, and then we'll go through some DFD rules and guidelines that you need to follow when you construct your data flow diagrams. And then I will go through briefly the meaning of CRUD technique or CRUD technique, and then uh, process descriptions, because when you construct your data flow diagrams there are use cases or there are processes basically, so we need to define these processes in detail. So we will learn how to define or describe your processes, and then we will move into data flow definitions. In your data flow diagrams there are lots of data flows in and out with the external agents, and also between some processes, so we need to define these data flows in detail. And then again you have entities in your diagram, entity data stores, so we need to define these entities a little bit more in detail. So process descriptions, data flow definitions, and data store definitions we constructed as a part of data dictionary, because when you construct or when you develop a system, as a part of a system analysis process, we have to construct a data dictionary. So that data dictionary created using these three parts. And then finally we will move into DFD quality, because once you construct your data flow diagrams, you need to check with using some rules, basic rules, whether these data flow diagrams that we have constructed comply with these basic rules. So we will learn these rules a little later on. Right, so this diagram shows our path. Now in I think in lecture 4, week 4, I have covered the basics. So when you define your requirements, you need to first capture the events in your system, and then use cases, and then you have to document events and use cases using event table, and also we have to define and identify user stories. So all of these will capture the requirements for the system, and then we need to find out what are the things or what are the objects we are going to record in our system. Sometimes we need to know the information about this object, the history, how the transaction flows within these objects. So that is why we capturing these things, right? So these things we model in structured approach using entity relationship diagrams. And in week 5 I have gone through some of the basic some of the models that we want to construct as a part of system analysis under this traditional or structured approach. The context diagram we have developed, and then the DFD fragments. Actually we first develop the DFD fragments and then develop the context diagrams, and then today we will move to the other models like data flow definitions, process description. So these are actually descriptive models rather than we are using any notation, and then other traditional models we are going to learn today. So let's first go through some of the revisions. DFD hierarchy. Now when you construct your data flow diagrams, the top highest diagram we called it as a context diagram. So context diagram basically shows you, it's actually it shows the bird's eye view of your system. It shows you the overview of your system. It shows you the boundary of the system or the scope of your system. And this context diagram shows all the external agents. So the external agents are the people or the any other subsystem or any other organizational entity external to the organization or internal to the organization whose activities are not comes under the scope of our system. So that is how we define the external agents. So these external agents are supplying information to our subsystem or the system, and also receives information from our system. So these external agents also shows in the context diagram. And then we are showing the major information flows between these so-called external agents and the systems, your subsystem. So these are the things that we are actually showing in your context diagram or the highest level diagram. It's a kind of a bird's eye view of the system. And then we can construct level 0 diagram. So level 0 diagram actually shows the major processes, data flows, data entities at a very high level detail. So basically when you construct your event table, uh, so each event has use cases. So these use cases probably very complex, right? Uh, so this event, each one event represent one process in your level 0 diagram. So level 0 diagram is basically primarily we use as a presentation tool. It summarizes the entire system or subsystem little bit in greater detail than the context diagram. Uh, so then we have studied the lower level data flow diagrams like level 1, level 2, etc., etc., because you can actually break down your complex processes in level 0 diagram into more lower level diagrams. So remember the example that we have done in last week or week 5. So if I go to very quickly week 5 lecture, remember that I have covered uh, the order entry subsystem context diagram. So when you define your event table, these are the major subsystems. So if you think about order entry subsystem, these are the use cases or the events or use cases that come up with the events. So what the business analyst does, they created a kind of a context diagram. So and then this context diagram actually based on these DFD fragments. So each event represent one fragment. So these fragments, once you combine, you can construct the level 0 diagram, right? And then if you go through this your fragments little bit more detail, you can see the level 2 diagram or level 2 fragment create new order, bit complicated because you can see there are lots of processing or the information flows in and out from the system, right? So what the analyst has done, he has developed this level 2 diagram which break down that process into more lower level processes. So basically level this DFD fragment actually comply with this. So all the inputs and outputs and the data stores or entities, and also these so-called external agent must represent as is in this diagram a little bit in detail. So that is what we have learned last week, right? So in this slide, actually, I have explained a little bit more detail about the level 0 diagram. So I have said earlier, it covers all the main processes or functions. It has all the main entities. It has all the external agents. So all the data flows between the system and external agents shows in that diagram. So remember that level 0 diagram must consist with the context diagram. So it has to have matched with the context diagram. So yes, as I mentioned earlier, some processes are a bit complicated, some processes are a bit complicated, so we need to explore a little bit more in detail. So we need to break down these processes into sub processes to show the additional processing details. So we named it as level 1, level 2, level 3, etc., etc. So remember, this numbering scheme doesn't equate to the execution sequence. So if you go through your previous week 5 uh, slides, you can see in the level 0 diagram, these numbers that we have put into the process does not mean the sequence. So you can actually put any numbers, but make sure that it is consistent. So so decomposition process actually stops at the presentation of the primitive process, but when you break it down, these processes into the more lower level, there's a one state, the time will come you cannot further develop any diagram, right? So that is what you mean by the primitive process. So you need to stop from there. So once it comes to the lowest level, you need to stop your breakdown or construct other DFT diagrams. So that is what the revision we have done in last week. Alright, now let's go through data flow diagrams, rules and guidelines. Now these rules and guidelines are very important. When you construct your data flow diagram, make sure that you adhere to these rules. Now data flow diagrams must have at least one process and must not have any freestanding objects or object connected to themselves. So remember, you must include more than one process in other words, more than one use case in your data flow diagram. So you can't have any freestanding objects, right? So for example, you can't have any data process or the use case or external agent without connecting to any object in your data flow diagram. So what are the objects that you can see in the data flow diagrams? So basically you can see external agents, you can see the processes, you can see process flows, or what you call this data flows, and then you have entities, right? So entities, processes, external agents has to have connections, so you can't have any freestanding object without any connection. Then the second rule, basic, what it says, a process must receive at least one data flow coming into the process and create at least one data flow leaving in the process. Yes. So when you create a data flow diagram, make sure in your uh, process, so each process must have one flow inside and one flow outside. It goes out from, because the processes represent the process of information, right? It has to be supplied to that process and the kind of a process going on, and then it has to record it back into a data store or the entity, or it has to go to an external agent, right? So must receive at least one data flow. Third one, the data store should be connected to at least one process, right? So when you come to a data entities, it has to connect to at least one process, right? It has to have data flows in and out from the data flow diagram, right? uh, so basically when it comes to the entities, you cannot connect entities with entities, right? So you need to connect entity with the data flow, right? It can go inside the flow, the information, and process it, and the information goes back to the data store. So what do you mean by going outside? So it actually means the reading and writing, or it mean reading or updating, or it maybe mean reading or deleting, right? So that is what we mean by that connection. The final one is external entities should not be connected to each other. Okay. Although they communicate independently, that communication is not part of the system we design using data flow diagram. So we are not interested in what's going on with external agent, because what we are interested in how external agent interacting with our system. So what kind of information they are supplying to the system. So what sort of information we are producing back to them, right? So we are not interested in connecting external agent with another external agent. So you can't do that in your data flow diagram. Data flow diagram rules and guidelines. Now let's go through these data flow diagrams and see whether we can pinpoint some errors. Right, now let's go through this left hand side diagrams. Now you can see this first diagram. It's a connection between external agent with an external agent, right? So this is actually illegal. You can't do that. So if you want to develop a data flow diagram, you want to have a process in between. So one external agent supplies information to our system, or the process actually process the information and then flows back to the external agent, right? So it can be a same external agent, or sometimes it can be another external agent. It doesn't matter. It depends depending on the context you are modeling. And in the second diagram, what it says, the external agent supplies information to the data store. So in other words, data store or the entity reads from the external agent and giving the information back to the external agent. Now this is also incorrect, because there is no process involved in this diagram. So the correct way is the right hand side diagram. So you must have a process. So external agent supplies information to the processor. Process the information and write it back to the data entity, right? So in order to process this information, sometimes uh, the process needs some information read from the entity as well, and process it and then write it back. So that is the correct way to model uh, this data flow context. And then the third diagram actually shows, now we have entity here and external agent. So entity supplies or gives information to external agent. So external agent, in other words, reads from the entity. Now that is incorrect, because if you want to get some information, you need to get it through the process. So process need to read the information to the process, and maybe it may process something and then gives back to the external agent. So this is the right way. The final diagram, now there's an exchange between one entity with another entity. Now that is also wrong, because in order to exchange the information between entities, it has to go through a process. A process may read some information from an entity and process the information and write it back to the another entity, right? So that is the correct way. So you can see there are illegal or incorrect ways of developing entity or data flow diagrams, or the fragments in other words, and then the right hand side, it shows you the correct way of developing your fragments. So make sure you apply these rules when you construct your data flow diagrams for your subsystem. Alright, now let's construct the event table for our scenario, hotel booking system. Remember in week 4 I have introduced this small hotel booking system. So this is the event table that we have created for that hotel booking system. Now let's go. So I will just go through very quickly the previous slides, right? In week 4 I have used this example, hotel booking system occurrences. Now first customer contacts the hotel to see if they have a room free for the following Saturday. So this is week 4 or lecture 4, slide number 37. And then the clerk checks the room booking and finds the free room, and the customer accepts the room and gives their personal details, name, address, etc., etc. to the clerk, and the customer pays the deposit by the credit card. Then the clerk updates the system to show the room is no longer free on Saturday, and that is booked to the customer. And then if you read the next line, you can see it says the customer rings in the following day. So that means this is another event. So you can see the first 5 occurrences actually it confined into a one event. So customer wants to book an hotel, right? So there is a one name. So all these 5 steps or 5 occurrences can be in a one event. And then if you read the next one, the customer rings the following day to order flowers for the room. This is added to the room booking for the inclusion on the bill. So that means that is another, this occurrence is another associated with another event. So separate event. Customer wants to order the flowers. Then if you read the next slide, it shows you another separate event actually. Then the customer turns up on Saturday and gives their name. Then the clerk uses the system to find the room number and gives the customer the room key. Then the clerk records that the room is now occupied. So when you read the next line, on Sunday the customer is leaving. Now this is the leaving. So that means the first 3 occurrences actually related to another event. So this is like a check-in event, right? And then Sunday the customer is leaving the hotel, the bill is calculated by the clerk, the customer pays the bill, and the clerk records the room is no longer occupied and that the customer has paid. Now you can see when you read these 4 key narrative the points, it related to another event, right? Customer actually checks out, right? So I can highlight or the record all these occurrences in a one single boxes grouped together, and then I have named each box as a use case. So I can put that into a event table, something like this. So we have events for these 5 use cases, then we have triggers, what triggers each event, then we have identified the external agent, so customer, and then the use cases as we just identified, and then the response from the system, right? So that goes to the customer. So this is what we have done in week 4. So once we have constructed that event table, so back to our week 6 slide, then what we can do, we can construct now fragments. So remember, we can construct fragment for each event, right? So how are we going to do that? So we have lots of information, all the information necessary for the fragment creation. So what we can do, we can create 5 fragments, right? So first one is the create new booking. External agent is the customer, okay? So customer make an inquiry. And then he pays the deposit, and then booking confirmation goes back to the customer. So in order to process that information, the system need to read data from room condition report. So room information goes into the system or reads by the system, right? So you can see this comply with your DFD event table, right? So response is room booking and the confirmation. So the trigger is customer inquiry. So we have the trigger, we have the response, and also we have another deposit, right? Because I haven't shown that in the event table, it's something new. So because something extra, we can show a little bit more in detail. And then fragment 2. Fragment 2 is actually the second record in our event table. Customer calling the form to order. So the use case or the process is fulfill order or the fulfill the service, right? So if I go through this fragment, the process is there. So I will number it by number 2, and the customer is external agent. Customer order goes in, or the order customer inquiry, the order phone inquiry, order phone inquiry goes into the system, so that information, and then order confirmation goes back to the customer. So in order to process that inquiry, uh, we need to read from, actually there is a reading as to have as well to find out the customer details, because it not shows in here, but we record it under the in our table called order records, right? But at the same time we are sending this order information to our supplier, right? And then the supplier send you an invoice or something, or we can call it as order items. Details comes in. So that is the second fragment. In this second fragment, the supply is not shown, right? That is the extra information that I have shown in the fragment. And the third fragment is check-in, organizing the check-in. So if I go through the third fragment, so organize check-in. So we have customers. Customer comes and inquire about the room, and then the process gives the key information or keys, or the information, actually this has to be key information. So with the key you will give some sort of an information, which room, blah blah blah. So all this information goes to the customer. And also customer is producing the booking confirmation, because we need to confirm whether this is the right customer, right? So booking confirmation details also supplied by the customer. So in order to process that information, in this hotel we need two entities: booking details and room condition. We need to read the booking information from the booking details in order to confirm whether this customer is a legitimate customer. And then once the key has given, we are updating our system in the room condition entity. And then the final one is the fourth one, organizing the checkout. Then the customer want to check out from the hotel. So this is the process. We have a use case, and these are the responses. So issuing the bill, receive the payment, update the room status. So organized checkout process, right? So customer is actually the checkout inquiry comes in, and then invoice is produced and given back to the customer, and the payment is comes to the from the customer to the process. So in order to process this information or data, so we need the invoice information entity and room condition entity. So we update in the room condition. So the arrow goes back from the process to entity. That is what we mean by the update. And then we update the payment with the pay invoice entity. So this is actually shows you the 4 fragments that we developed for this hotel system. So once you have developed these fragments, it's easier for us to now develop context diagram and level 0 diagram. So level 0 diagram, once you, it's very easy. So what you have to do is you have to combine these 4 processes or use cases with single one diagram, right? So what you need to make sure is all the inputs and outputs has to match with this diagram. Okay, so you can see the custom is we put the custom into 2 boxes because this shows you the duplication of the customer, because we can't show the customer twice usually. So if anything is duplicate, we can show it something like this with the cross line in your customer entity. So basically we have 2 external agents in this system: customer, supplier, that's it. And then we have around 5 entities used in this system as well. So that is all about DFT fragments and level 0 diagram. CRUD technique. Now CRUD is actually we use to validate and refine some use cases. Sometimes we need to find sometimes new use cases, we can use the CRUD technique. So basically we try to match the existing use cases that we identified in your event table with data entities. So the entities or the we can sometimes call it as domain classes, because we match each use cases with these entities with these instances, because each entity must have a create instance, read instance, update instance, or the delete instance. So we need to find out whether all these 4 instances represented in our identified use cases. Now I have given some guide to the CRUD technique. So first we need to identify the data items or data entities to be handled by the system. For example, online ordering website, data items can be related to the customer, right? So customer can be a one data item or the data entity. Order can be a another data entity. Inventory item, order line item, maybe another entity. And also we may have shipment entity, right? Then we need to examine each data item or data entity, and then we need to state the use cases that related with creating the data, reading the data, updating the data, and deleting the data, right? So I have given an example in the next slide. In this case, this is the example. So in that example, we have customers, order, inventory items, and shipment. And then for each entity, I have these 4 instances. And then I have find it out whether I have identified a proper use case to cover each of these. So if you miss something, then you can actually include a new fresh use case for that, right? So you can actually use this kind of table as well in order to find out the use cases. So in this case, I have put all the use cases and entities, and then try to find out what does each use case doing for each entity, right? So you can see the first use case is creating a custom instance, and the second use case reading an instance from the customer. In order to find the customer, we need to read it. Third use case, again read the instances in order to produce the customer list. right? So likewise, we can go through each and every use case and the entity and match and see whether there is a unmatched one, right? So likewise, you can identify the new use case, or you can refine the existing use case. Right, documentation of data flow diagram components. So as you know, data flow diagrams, you graphically summarizing the interactions among three types of internal system components: processes, data flows, data stores, and then also external agents. But additional details about each component need to be described. First, each lower level process need to be described in a little bit more in detail. In addition, the business analyst need to define each data flow in terms of data element it contains. Data entities also need to be defined in terms of data elements. And finally, business analysts also need to define each data element in detail. So let's go through how to document these lower level processes. So documentation of lowest level processes. Now you know each process on data flow diagram or each use case in the data flow diagram we need to define formally in detail. So there are several options for the process definitions. Uh, uh, one way of defining the process is, you already know that we can decompose the processes. Now process decompose means we are breaking down the higher level context diagram, we decompose into level 0 diagram. So level 0 diagram we can decompose into level 1, level 2, etc, etc, and then we have data flow fragments. So eventually there is a point probably we may have reached at which a process doesn't need to be defined further by data flow diagram, right? So this point occurs when a process becomes very simple that it can be described maybe adequately by some other methods. Probably maybe you can use a structured English, right? So for example, if you use a structured English to describe the process, so we need to actually describe like an algorithm, that how the processes are flowing using a kind of algorithmic language. Now, when the process described as an algorithm, the business analyst probably choose the most appropriate presentation format. So determining which is the most compact or readable and unambiguous method. Well, there are some other methods also as well, because we can use some methods like decision tables or decision trees instead of structured English to describe the processing activities. So structured English actually the most preferred method usually to describe the process a little bit more in detail. So what do you mean by the structured English? So structured English actually uses brief statements to describe a process very carefully. Structured English looks like programming statements actually, but without referring to the computer concepts. We are using the English language. Now, now we need to think about this also. There are some rules of structured programming. So these rules of structured programming need to be followed in order to for a kind of a clarity purpose. Now let's go through a simple example which shows you the processing of ballot boxes or ballots after the vote. So this example actually shows you how to use a structured English to define some primitive process. So this is an example of how to process the ballots. Now you can see some statements here are very simple instructions. Other statements are repeat instructions. So some statements are direct the program to execute one set of instruction or the other set of instruction, like a if statement, right? The procedure always start at the you know always start with the top and ends with the bottom, right? So that is how the procedures work in a structured program. So it starts from the first and ends at the bottom. So therefore the structured programming rules applied in this kind of process description. So you can see first we collect the ballot boxes, then place all the ballot boxes in the stack and set as the count and no count zero. So we can put the 0 to the count, and then we have a loop, right? And inside this loop we have set of instructions, and then inside that loop we also have some conditional statements that we check some conditions, right? So likewise you can develop process descriptions, right? So this is another example. This example is for our Ridgeline Mountain Outfitters process 2.1. So process 2.1 is recording the customer information. I think if you go through my week 5 lecture slide, you may have taken like process 2. Alright, so this is the 2.1 slide number, I think figure number 522. So we are recording customer information, right? So this is the breakdown of this is the diagram 2 process, right? So this process, recording customer information, described in detail in this process description. So you can see the order details comes in, and we write the order details back to customer, and then the order details pass to another process. Okay, so that actually described using this structured English method. It looks like a structured programming using in English language. Right, so once you define the processes, once you define your processes, the lower level processes in details, the next step is we need to document the DFD components. So we need to define or describe the contents of the data flow, and we need to describe data entities and its elements, and each data element we need to describe using some sort of annotations. So let's go through how we going to create a data dictionary. So we need to now create a data dictionary, right? So once we have once we have identified all the elements, we need to now create the data dictionary. So when you create the data dictionary, we can create data dictionaries in two ways. We can create logical data dictionary, or we can create a physical data dictionary. So logical data dictionaries basically describe the logical flow of information in your processes. Basically, when you identify the entities, so for example, if you identify a custom entity, it can include customer number, customer name, and then addresses, so maybe the orders that the customer has been made, the relationship with other entities, blah blah. So all these kind of things are called the logical elements, right? And then we also can actually create the physical data entity in data dictionary. The physical data dictionary actually shows you the physical attributes of data element. For example, what kind of data type. So is it a varchar type, or is it integers, numbers, date types? What is the length of the data? What is the format of data? what is the data recording standards, so where is the physically the data is going to store, whether it's what are the database name, columns, rows, etc. So all these physical aspects or attributes we described using physical data dictionaries. So now let's go through some logical data dictionary example. Right, so before we move into an example, when you construct a data dictionary, you remember we need to use some symbols, right? Now, when you construct a data dictionary, as I told you before, you can construct the data dictionary for data flows, data stores, and data elements, right? Now, when it comes to data flows, we need to use some sort of symbols to represent the structure, element, and blah blah blah. So, using some sort of symbols. Now, there are some notations that you can use to explain the data flows or the data contents, data flow contents. So these are the symbols we had to use. Uh, Now, if you use the equal sign shows you the composition of the contents. The meaning of equal sign is a composed of. For instance, the order or custom order, say for example the custom order comes from the custom external agent customer to our process. So custom order consists of, so we put the equal sign and then we write the elements in that custom order, right? So when you write these elements you need to use probably the concatenation symbol or this plus symbol. So plus symbol shows you addition. So custom order consists of maybe custom ID plus item list, right? And then we can sometimes use braces. So braces we shows the iterative items, multiple occurrences. Now for example, one custom order can consist of multiple order line items. So we can show these line items in the braces. Right, so if you use, for example, if you record line item ID plus description inside the curly braces, that is called this line item ID, and the description repeats for each line item. And then sometimes we can use the brackets with this hyphen to show the selection. It's a selecting of an alternative. Sometimes we can give a customer to select yes or no, right? Or something else, some logical selection. So we can use these brackets and this hyphen to show that. We use also parentheses for the optional items. So if you use the parentheses, it shows you may or may not be present in your data flow, right? Customer probably can give their phone number with the custom order, right? So it is optional. So that phone number is probably can put it inside the parentheses. Then if you have a discrete value, we have to use the quotation marks, right? So that shows the value of the variable. Sometimes we need to use the comments, right? So in some data flows we need to use the comments to show what type of data or what do you mean by this data flow. So we can use the asterisk to show this additional information. Now let's go through a uh, data flow example, how to use this notation to define the data flow. Right, so this example shows you how to define your data flows or logical data flows. We can call it as logical data flows. Now example number one is example of a composition and concatenation. Customer address, right? So if you have a data flows, for example, customer address, it consists of equal sign, customer number plus street plus city plus state plus postcode. So you can say the composition sign and concatenation symbol, right? So this reads as something like this. Custom address consists of number, street, city, state, postcode, right? So second example. Now second example shows you an iteration. Okay, so let's go to these two examples. Order consists of customer name, customer address, and inside the curly brackets number of items. So that is why we put the curly braces. And then we need to tell again, we need to define what do we mean by this item. So item consists of product code, product description, product number, product number ordered, and product price. Right, so that will actually repeat for all items in that order. That is what we mean by these curly braces. Example number 3 is an example for a selection and the optional. Customer name consists of courtesy title, first name plus the optional middle name inside the brackets and the last name, right? And then we define the courtesy title a little bit more in detail. Courtesy title consists of one of these options: Mr., Miss, Mrs., Doctor, Professor, right? So discrete values, make sure you put inside the quotes. Fourth example, comment and discrete value again. So credit agency response data flow equal to, and then I have given the comment. So because what do you mean by this? Sometimes it bit confused for developers to understand it, so we can give a comments using the asterisks. So this is the response from the credit card agency to a request for a change authorization, right? So that actually consists of a kind of a selection, yes or no. And then final one is again another example of a comment. Weight, what do you mean by the weight? Weight is person's weight on entering the hospital. The units of weight is kilograms, range is between 1 to 200. Right, so we describe this weight detail using a comment because there's no other way we use it. We can describe it using the notation, so we use the comment symbol. Right, now this example show again the data dictionary example. This is a physical data flow or data store. So this is actually define the data stores, right, in your data dictionary or entities. Okay, so physical properties. So these data flows which I have described earlier, these are maybe related with the external agent and the process. And then that information goes to the entities, right? We need to record this information in the entities. So that entities we need to actually describe the properties of the entities. So that is called the physical descriptions. So physical data description, now this example is the customer. This is data dictionary item for the custom entity. Right, so this is typically you have actually studied database analysis and design subject. You know how to write a create table statement. So in the create table statement, we identify the columns, we identify the attributes or the columns or attributes, then the data format and the size of the data, right? So there are lots of things we have. So you actually describe that schema as a data dictionary. So this is actually this example I used using Microsoft Access example. So you can see I have identified each column, whether it is a primary key or the foreign key, right? And then the column name, and then caption, and data type of each column. It can be varchar or number or date type, and the size of each column, and some notes. So that is an example of physical uh, uh, data store or data flow descriptions. So now remember, when you define your when you construct your data dictionary for your subsystem, you need to define data flow contents using the notations I have described, and then you need to describe the elements in your data stores with detail. Actually, that ends our structured or traditional analysis models. So we have studied data flow diagrams, then process definitions, entity relationship diagrams we have studied in that, and also data definitions in data flow descriptions. So all these items actually gives you a complete set of requirements analysis and models. Alright, now let's go through how you're going to evaluate the quality of the data flow diagrams that you have built. The high quality set of data flow diagrams, usually more readable, is internally consistent and accurately represent your system requirements, right? So accuracy of representation determined by primarily by consulting or interviewing the users and other knowledgeable stakeholders. So because if we want to confirm whether it's accurately represent the requirement, we need to consult the users. There's no other way that we can determine the accuracy of your developed models. Usually the project team can ensure this readability and the internal consistency by applying very simple few rules when they construct the DFD models. So business analysts can apply these rules while developing the data flow diagrams or during a separate quality check after preparing the data flow diagram drafts. So one important thing that we need to remember is how we're going to minimize the complexity associated in the diagrams. So people have very limited ability to manipulate complex information. If there are too much of information presented at once, people experience a phenomena called information overload. I think you have learned that in your some other subject. So when the information overload occurs, the person has very difficulty to understand, right, some information or something. The key to avoid this information overload is to divide the information into very smaller component or relatively independent subsets actually. So each subset should contain a comprehensible amount of information that people can examine and understand in isolation basically, right? So a layered set of data flow diagram is a classic example of dividing large set of information into small independent subset. So each data flow diagram can be examined in isolation. So the reader can find additional details about the specific process, probably by moving down to the next level of data flow diagram, or find information about how data flow diagrams related to other data flow diagrams by examining the next higher level of data flow diagrams, right? Uh, so the analyst Analysts can avoid the information overload with any single data flow diagram by following two simple rules of data flow diagram constructions, right? So the first rule is called 7 plus or minus 2 rule, and the second rule is called we try to minimize information what do you call, sorry, minimize the interfaces in your uh, data flow diagram. All right, uh, so let's go. What do you mean by uh, 7 plus or minus rule? 7 plus or minus 2, or we call it as Miller's number. So the Miller's number rule, we call as rule 7 plus or minus 2, derived from a psychology research actually, which shows that the number of information or the number of chunks that the person can remember and manipulate at one time, it varies between a 5 and a 9, right? So large number of chunks causes information overload. So information chunks can be many things. It can be include names, it can be words, list of words, it can be even digits, right, or components of a picture, right? So some applications of uh, 7 plus or minus 2 rule in DFD contents can be something like this, because sometimes we need to have a single data flow diagram. If you think about single data flow diagram, it should not have more than 7 plus or minus 2 processes basically, uh, or no more than 7 plus or minus 2 data flows should be enter or leave into a process, so enter or leave into a data store or data element on a single data flow diagram. So these are the general guidelines, not unbreakable laws actually. So data flow diagrams that violate these rules may still be readable, but violation should be considered of a warning sign of a potential problem. Okay, so that is what we need to understand, how we're going to avoid this. So let's go through some of these. So ensuring the data flow consistency. Now, when business analysts, sometimes business analysts can often detect errors and omissions in a set of data flow diagrams by looking for specific type of inconsistencies, right? So there are three common and easily identified consistency errors that we can learn. The first one is differences in data flow content between a process and its process decomposition. So we can go through the higher order data flow diagrams and see the contents of data flows, and then we can compare that with the process decomposition or process the decompose or the lower level diagrams, and see whether we are representing the same logic in these diagrams. Second one is data outflows without corresponding to data inflows. So if there is a data output from your process, you need to think, aha, did I have some corresponding data input to the process, or am I read something from an entity, right? So that is another cross check that you can do. The third simple rule is data inflows without corresponding to data outflows, right? So whatever the going out from your system has to be have an inflow into the process, right? So these are the three small checks that we can do. So a process decomposition actually shows the internal details of higher level processes in more detailed form. So in most cases, data contents of flows, the flows into and from a process at one data flow diagram level should be equivalent to the contents of data flows and from the processes in the decomposition level, right? So this equivalency we usually call it as balancing. And the high level data flow diagrams and the process decomposition data flow diagrams are said to be in balance, right? Now what you need to be careful is we are using the data content, right? uh, Data flow names can vary among data flow DFD levels, right? For a number of reasons, because sometimes decomposition of one combined data flow into several data flows can be, very easy to record, be easy to show. Therefore, business analysts must be very careful to look at the component of data flows in the lower level and the higher level, right? Not just the data flow names. And don't just go through the data flow names. You need to find out the contents. So for this reason, detailed analysis of balancing should be undertaken until data flows has been fully defined by our system, right? So we need to define it using these notations. Once you define everything, data flows, data source, then of course you can do this balancing activity. So usually unbalanced data flow diagrams may be acceptable when the imbalance is the imbalance is more we can actually, if it is a higher level diagram, so imbalance is okay. Because if you think about the diagram 0 for a very larger system, it can ignore the details of error handling, right? For example, when the item is ordered but the later determined to be out of stock and discontinued by the manufacturer, so we can have kind of a error handling in the lower level diagram. So we can actually ignore that kind of data flows in our higher level diagrams. So these kind of inconsistencies can be, that is what we mean by the balancing, right? So let's go through the other uh, data flow balancing problems, or the problems in the data flow. How are you going to avoid this? Now what we need to avoid in data flow diagram is the black holes and the miracles, right? The black hole is a process or data store with the data input that is never used to produce any output. So we are inputting the data into a process, but it's a black hole. So black hole means we don't know where this data goes in, right? So we never use this data input into the process in our system, right? That is called the black hole. Now miracle is the other hand, it's a kind of a we create something from the process without entering corresponding data into the system or into the process. This is called the miracle. So let's go through some examples. Right, now this example shows you the black hole. Now you can see here, this is one fragment. Check item availability. Now customer is external agent. Customer is uh, sending the order information, and then the system is producing item availability details back to the customer. So in order to produce order item availability details, now see the black hole. Where is the black hole creates? Now here in this, business analyst grabs information from the catalog. The catalog is where you put all the item information, and it take the order information, it take order item information, order transaction information, then the product item information, return item information. So you can see there are some data is unnecessarily comes into the system, but we never use it to produce the item availability detail. What we need is the catalog information and product item information only. So there is a black hole, unnecessary data input. So you need to avoid that. Make sure when you produce some information, right, make sure you capture only the required ones. So avoid the black holes in your subsystem. Now this is an example of a miracle or process with the impossible data output. Now let's go through this process. Now this process producing the class lists, and that class list goes to the faculty member external agent. So what this business analyst does, in order to produce the class list, he is reading the student information. So can we produce a class list by reading the student information? No, you can't. So this is a miracle. How miracle you can produce this information with the student information? So that is wrong. So what we need to do is, we need the student, in order to produce the class list, we need the student information, we need courses offered, and we need course enrollment details. Once we grab all these three information, only we can produce the class list. So this is a miracle. So please avoid the miracle. Right. So let's go through another example. Now this actually shows you a process that we produce the result X. So in order to produce result X, this process takes A, B, C and X. Right, now let's go through this process. Now in the structured English, they have actually shows you what is inside this process. Now what this process does, it compares. If A is greater than 5, then X value is X times 1.05. Otherwise X value is X times 1.10. Right? So you can see, in order to produce X value of X, you need only the value of A. You don't need value of B and C. Of course you need A and X, right? So you are sending variable A and variable X, and you are recomputing X value and submit. So you don't need B value and C value. This is unnecessary data input. Another example. Now here the example shows you the impossible data output. So this process Y takes A information and produce A, B and Y. So let's see. So according to this process, we calculate Y value if A is greater than 5. Y is 100. Otherwise the Y value is 250. So what we need is, we are giving A, yes, good, and we are producing Y value, and we also are producing A value. We don't need the B value. Where is the B value coming from? So in order to compute this, there is no B value is taken into account, so we don't need this B value. So this is called impossible data output example. So please avoid that kind of unlogical output from your system. Right, so this example actually shows you a faulty data flow diagram, and you need to find out the errors. Now in your test you will get these kind of data flow diagrams, and you need to find out the errors. So let's go through this process diagram or this data flow diagram. So what are the errors you can see here? So we have external. Now first we have to find out what is actually going on. So we have employees and we have account receivable department. It looks like human resource or some sort of a membership, actually membership system. So employees sending the application, member application, to the process called create new member account, So in order to create new member account, it reads from the member accounts details, so that is correct, and it reads from employee table about the employee status. Right, now there is a problem here. You can see information comes in, but there is no way the information goes back. It's stuck in this process, right? So it looks like a black hole now, right? So there is no nothing goes out from this process. So this is an error. Okay. So let's go to 3.13 process, freeze member account number. In order to freeze member account number, right, it's just updating the member account or new account status question. So this is correct. Frozen account notification goes to account receivable. Right, so this is actually probably okay, because this can be a kind of a state event associated process. So there is a no connection, or maybe a temporal event associated process. So there is no activation comes in, or the process data comes in. So this is quite okay in this side. Okay. Right, so let's jump to the process 3.1.1. So here this process generating an employee bank statement. Okay, so in order to generate employee bank statement, it reads from employee addresses from the employee table. Okay, employee addresses from the employee table and produce a bank statement. Now this is a kind of a miracle, right? So how can we produce employee bank statement with employee data? So there is a one entity is missing here in this case, right? So there is an error in this particular data flow, this particular process. So there is actually a miracle. So likewise, you should be able to find out the errors in data flow diagram. So go through all these rules and find out whether you have breached these rules in your data flow diagram. Right, so that is the end of week 6 lecture, and I hope that you have enjoyed the lecture content. Please go through the concepts once again. So that actually concludes our structured analysis part. So we are now moving into, in our future lectures, we are moving into object-oriented analysis. Thank you.